this is the example number 1. Y double dash plus y dash plus 2 into y equals to 5x minus 3. So it can be written in terms of the differential operator, that is d square, that means d2y by dx square y double dash plus d, that means y dash dy by dx plus 2 into y. Y gets common, so equals to 5x minus 3. So it can be written in the form of the differential operators, linear differential operators, but it cannot be factorized further. So we cannot write it in the terms of factors. Okay, we have example number 2 next. That is d square plus 5 into d plus 6 into common into y equals to, we make factors now. So 5d has the factors 2 and 3. So if I make it like d square plus 3d plus 2d plus 6, then it can be factorized as d plus 2 into d plus 3 into y. So if I suppose that if I suppose that w equals to d plus 3 into y, that means y dash plus 3 into y. So if I replace this d plus 3 into y as w, then it becomes d plus w into 2, and that means d into w plus 2 into w. So if I replace this as y dash plus 3 into y, so that means, plus 2 into, I replace the value of w, that is y dash plus 3 into y. So derivative of d of y dash, that means d by dy of y dash, that means d2y by dx square y double dash plus 3y dash. Now y becomes y dash, so dy dash and plus 2y dash plus 6y, that makes it y double dash plus 5y dash plus 6 into y. So definitely you can see that this can be written as, this differential operator, linear differential operator, can be written in terms of the differential equation. D square plus 5d plus 6 can be written in terms of y double dash plus 5y dash plus 6y dash. In the first example, differential equation was given and we write in terms of the differential operator, and in the second example differential operator was given, equation was given, and we write it in terms of this derivative differentials. Differential equations. So in third example we can write now in this form y double dash, and I can also make the factors of this, as I know that I can see that d square plus 4 into d plus 4, that means that it is a complete square of d plus 2, a plus b whole square into y equals to 0. Factors of it is d plus 2 into d plus 2 into y equals to 0. So I can also use as the linearity property, and step by step I can, so it can also be written as this. So I can relate it, and it becomes, if I write directly into the differential equation, then it becomes y double dash plus 4y dash plus 4y equals to 0. So this differential operator can be written in terms of differential equation. So these are the basic examples of the differential operators. So if L is a linear differential operator, that means it is a differential operator, but it is a combination of different differential operators, or differential operators, linear combination with the constant coefficients. So if L is a linear differential operator with constant coefficients and y equals to f of x, is a sufficiently differentiable function. It is a differentiable function such that L of y makes it 0 equals to 0. So then L is said to be an annihilator of the function. So L is said to be the annihilator operator or annihilator of the function. And the word annihilator or annihilation means to destroy or completely finish that something, anything, it can be anything. So in this, annihilator operator means that it completely vanishes or finishes the function. So that means L is said to be here the annihilator of the function. So if, for example, if y equals to k, then because it is a constant, so d of k is equal to 0. So if I apply the derivative d on k constant, that makes it 0. So d of k is the annihilator. D is here the annihilator operator, right? And also if I have if y is equal to x, then I think you have to differentiate it. First time it becomes 1, that is a constant. You have to differentiate it second time, that makes it 0. So it means d square of the function x, d square is the annihilator operator of this particular function. Also if I move further and if I have y equals to x square, so how many times x have to be differentiated so that it becomes 0? You have to differentiate it once, it becomes 2x. You have to differentiate it twice, it becomes 2. 2x becomes 2, constant. You have to differentiate it thrice, it becomes d cube of x. So that means d cube here is the annihilator operator, and so on. And if I generalize it, then and if it is a x to the power n, so how many times it has to be differentiated? It has to be differentiated n plus 1 times. So its annihilator operator is d to the power n plus 1. So that is the annihilator operator. And also if we have x to the power n minus 1, then its annihilator operator is dn of x to the power n. That makes it 0. So this is the basic concept of the annihilator operator. So as a consequence, the differentiation can be done term by term. So the polynomial or can be written in the linear combination can be annihilated by finding an operator that annihilates the highest power of x. So if that means if you have a polynomial function, like you have a polynomial function, for example, the combination a0 plus a1 into x plus a2 into x square up to an x to the power, or I can write it as an minus 1 x to the power n minus 1. So its annihilator operator depends upon the highest power of x. So this function or this complete polynomial function can become 0 if I differentiate this function up to n times, not n minus 1. It's one order greater than or higher than the given term, so that it becomes 0. So its annihilator operator depends upon the highest exponent or highest power of the respective variable. So it can be annihilated by finding an operator that annihilates the highest power of x. So this is all about the annihilator operator. Find the differential operator, or we can say find annihilator operator, or we can say differential operator that annihilates the function 1 minus 5x square plus 8x cube. So this operator definitely it is a polynomial function. It's a cubic polynomial function, and we have the highest power is x cube, so annihilator is one power greater than, one order greater than the highest power. So definitely you can see that its annihilator operator is d to the power 4. So that means d to the power 4, 1 minus 5x square plus 8x cube is equal to 0. If you have functions like e to the power alpha x and x e to the power alpha x, you cannot from that you cannot judge the highest power of the highest power of the variable, or you cannot directly see the annihilator operator power. So if you have these type of functions like x square e to the power alpha x and up to so on, like x to the power n minus 1 e to the power alpha x, then minus alpha to the power n annihilates each of the functions. So its annihilator operator is d minus alpha to the power. And note that the auxiliary equation of the homogeneous equation is this homogeneous equation. The auxiliary equation of this homogeneous equation is m minus alpha to the power n equals to 0. You can make a characteristic equation or auxiliary equation from this differential equation. That means that this is the annihilator operator of these type of functions. So that means that the auxiliary that the homogeneous differential equation of these type of functions becomes d minus alpha to the power n into y equals to 0. So the auxiliary equation of this differential equation can be written as characteristic equation is m a minus alpha into the power n, and y can not be written in the auxiliary equation as I mentioned it earlier in the higher order homogeneous differential equations. So you know that m minus alpha to the power n, that means it is multiplied n times. So that falls in the category of the case 2, repeated real roots. We have n times m minus alpha. We have the root because the root here is m equals to alpha. So that is n times. So we have to write the equation is the solution basically is c1 e to the power alpha x plus, because it is again and again it is the root and it is n times, so c2 x e to the power alpha x, and the last would be up to so on cn x to the power n minus 1 l e to the power alpha x. So it annihilates this type of combination. This is basically the proof of we can derive the annihilator operators, we can extract the annihilator operators among the equations that contains the exponential function.